choose between the fixed effect and random effect. So today we will talk about what it means by panel, and then we will use something like the pool OS, right? To actually, pool OS actually is something like what we discussed in the class in the OS. We based on the ordinary square approach, but instead of pooling, right, we pool them together. So it's called it as a pool OS. The pool OS means that it's a pool ordinary square approach. Then because of this, maybe I briefly explain why we have three different types of models we're going to introduce today. So one is a classical one, is called pool OS. Another one is called fixed effect model. And the third one is a random effect model. We're going to learn these three different models today. So what are the difference is, have you heard about this individual effect? Maybe I can say, because we are focused on the country, right? Maybe I can relate to the country characteristic. Each country has their own characteristic, right? If I put them together, is it suitable? Maybe you say yes, right? Yeah, we can put them together to come up with one conclusion. Yeah, for example, we don't talk about these developed countries' imaginary models. We talk about the economic growth. Let's say, can I pull all the advanced economies? Maybe I can say, is the economic growth in the advanced countries same like the Asian countries? Totally different, right? Is it different? Are they different? Different. So if you want to study about the economic growth model, if I pull them together to study the determinant of the economic growth, what will happen? What is going to happen? You're going to be biased, right? Because I ignore about this country characteristic. So that's why there is a lot of the limitation in the pool OS. So people bring out the issue like the fixed effect models as well as the random effect models to tackle this what we say this individual effect. So that's what we want to focus today. How to tackle this individual effect, either assume it random or either capture it with the constant. So let's take a look at our definition first. So you can open this. So this is our work file today, right? Yeah, the type of the panel regression. This is our topic today. Yeah. So what we're going to touch on today's lecture is pool OS. OS is called ordinary square model. Ordinary square, for those that not familiar with this OS, right? We use as an abbreviation. Is called it as an ordinary square. So we will start with the pool OS model. Actually, it's just a OS in the time series, but we put it in the panel setting. So we call it as a pool OS model. Then we will further to the fixed effect estimation. And this fixed effect, I can maybe can split into three. One is the least square dummy variable estimator, then the fixed effect estimator, as well as the issue with this fixed effect model. Then the third model we're going to discuss is the random effect model. Then next week we're going to use some diagnostic check, because all these three, right, we don't know whether country characteristic or individual effect actually matters or not, right? Because we are data-driven based analysis, so maybe in a data set you found there is an individual effect, but maybe in another data sign there is no individual effect. So we need to rely on this what we say statistical diagnostic check to diagnose it, whether there is a individual effect, whether there is maybe we can further to the cross dependency. So for us to choose between the pool, fixed, as well as the random, that we're going to discuss next week. So now, what is panel data? Yeah, so I think in the first lecture we talked about the panel data, right? So what is panel data? Actually, it's we also call it as a longitudinal. Some research, right, the journal papers they publish, they love to use this fancy terms. They call it as a longitudinal, actually refer to the panel, right? Longitudinal actually refer to the panel. So it's actually the simple idea is combine the time series together with the cross section. For example, the mind demand, what we applied in the previous lecture is just focus on Malaysian case. Alright, we just focus on Malaysian case. Let's say I want to study the mind demand in ASEAN 5. So I combine. So I'm going to have times right across the time, as well as I have 5 countries. So I have a time as well as the cross-sectional data may focus on 5. If I estimate them simultaneously, actually that's called panel data analysis. Okay. So observation in the same variables, right? So we focus on the same dependence and also a set of independent variables, and from the same cross-sectional sample. So we just focus on the ASEAN 5, like we say, follow the time, and then ASEAN 5. So I have T. So there is more than different time period. Like it means that if we just focus on, let's say, how many countries in the world? 100 over, right? I think 100 over countries. If you type, maybe it's 100 something. So 100 countries. Let's say my previous, I got one group assignment I received quite impressed. They focus on the corruption in the country, for all the countries in the world. So they just use the cross-sectional analysis to estimate for their group assignment. So there is a cross-sectional analysis on just one point of time. So just a single point of time, and then combination of all the countries in the world. All the countries in the world, there is a kind of the cross-sectional analysis. But if you want to study about the corruption for all the countries in the world, and then from time, like for example, 1980 up to 2023 or 24, there is a type of the panel data analysis. So what are the reasons? So why we want to use this panel? So as we discussed in the first week lecture, right? So that we have understand that there are many kind of something like advantages by using panel. So not only that account for individual specific heterogeneity, we also can combine the data into 2 dimensions. So we can have more flexibility like in our analysis. And also we can reduce the multi-collinearity. Because if we focus on the something like the time series, let's say, because one thing I did not touch on our time series analysis, for example, like ARDLs, right? During the ARDL lecture. So if I use the correlation to test the correlations amongst the independent variables, for example, you most likely will get the correlation between the money, between the GDP and also money supply, maybe income, yeah. Then might be highly correlated. For example, like maybe between the GDP, between the CPI, there is trend upward, right? These 2 series might be highly correlated. And if we ignore this multi-collinearity, what we're going to be in our analysis? Our analysis is going to be biased. Why? Because if there is a presence of the multi-collinearity, our standard errors, our test statistic no longer reliable. So if we use the panel, then we can reduce this problem because we do not need to care much about this multi-collinearity, and we're going to earn more degree of freedoms. Why? What means a degree of freedom? Because for our estimation to be valid, right, we need to have enough degree of freedom. Let's say the corruption. Why my previous group assignment means that my student group assignment they focus on corruption in the world, right? In the world, then they got 100 over observation, just focus on one point in time. Why they want to do that? Because maybe due to the data is not available for the longer period. They're just available like the few years only. So if you just have a few years, for example, right, like 3-4 years, then it's impossible for us to run the time series analysis or even though cross-sectional, unless you extend your sample to become like over 50-60 countries, right? So in order for you to have enough degree of freedom. So one of the reasons people proceed to the panel is due to the increase the sample size. So we have a more degree of freedoms. So in order for us to perform the reliable diagnostic check as well as the hypothesis testing. And the panel is better suited than cross-sectional data to study the dynamic of change. Because if you want to, for example, you want to study about my demands in ASEAN 5, then different country will provide you different result, right? So can you draw one conclusion for this ASEAN 5 country? It's very difficult, right? Because monetary policy respond to each variables will be different across the country. Maybe China will respond differently, maybe the Indonesia will respond differently. So how we come up with one valid conclusion? That's why people that use the panel in order for you to study, make one conclusion for all the ASEAN 5. But you have to make sure you get the correct analytic in your panel. Because once you pull, for example, start with the pool, right? Once you put them together in one panel, so for example, is it Malawi is one of the outliers, right? Because we cannot say I focus on developed country, then I put in one emerging market inside. So the country is important enough for you to, it means that you have to be wise to select the appropriate country in your panel. So what else? Panel is, you can measure effect cannot be observed in either cross-sectional or time series. Like I said just now, time series just focus on over the time, right, for each country, for example. How about the cross-sectional, right, the corruption for all over the world, right? So panel is different. They have, you can combine them together. So you have an advantage as compared to the cross-sectional or time series individually. And the panel enable you to be study the more complex. So you can study about the effect of technological change. You can apply recent tools, for example, the threshold, right, panel threshold, and then others that to study about the recent topics. And the panel can minimize the aggregation bias. Why? Let's say the economic growth models, right? Economic growth is aggregate levels. So then, is it any different compared to the industry growth data set? Different, right? Because economic growth in the aggregate, industry growth is this aggregate level. If we just focus on economic growth in the general, so actually we will fall in the what we call as aggregate bias. That's why people more focus on the micro side, microeconometrics. So they are more focused on the industry growth instead of national growth. So if you want to use this industry growth, because there are so many industry, right? So how are we going to study? Am I going to study time series country by country? Cannot be, right? Because means that the industry by industry cannot be, because it's very tedious. So why not you can use this panel to minimize the aggregation bias by focus on the industry growth instead of the national growth levels. This is one of the discussion in the microeconometrics. And if you proceed, it means that one of the advantage by using the panel is increase the precision. Because of this, maybe we cannot say using the time series less precise, right? We cannot say cross-sectional less precise. Is if we have several of these multi-quantitative, if you do not have enough degree of freedom, so the panel will provide you precise regression estimate. Okay? That is used to account the limitation in the time series as well as the cross-sectional, which is the difference, something like different case by case, right? I cannot observe, the time series have a limitation, so I just straightforward use the panel, not necessary, right? If you have enough degree of freedom, if you have can achieve an objective, time series actually can provide you the precise estimation. Depends on your research objective. And by using panel, you can control for the fixed effect. And actually, in summary, right, you can summarize them into at least three reasons for you to use the panel. Increase sample size, and can help you to provide the perspective that cannot be observed by using time series or cross-sectional. And to avoid these omitted variable problems, this actually, because sometimes, right, if you use the panel, right, actually you can have an unbalanced panel, right? So you can it's something like which you can have this omitted variable to try to avoid these omitted variable problems, because certain variable actually is not available in enough time, right? Enough time. So let's say the corruption only available, for example, like the five data point only, but other variable available in 10 data point. So you can use the panel to estimate such equation by focusing on unbalanced panel. So there is sometimes people say proceed to the panel in order to get rid of this, in order for you to exclude out the certain variable due to not enough of the observation. So today we focus on this traditional panel estimation, which are the POOS, fixed effect and random effect. Actually, we also have a micro panel. So micro panel which focus on this GMM method. For this GMM methods, right, you have at least in something like in minimum sample. So from my understanding, from I go through the journal articles, right, minimum samples means that minimum country, for example, or minimum industry that you focus, it have to be more than 50, more than 50. All of this actually is I and T, including combination of the cross-sectional together with the time series. So for the micro panel, minimum I is 50 above, in order for you to get a precise estimation. Then after we finish all these three, then we go further to this macro panel, which we're going to discuss in the after semester break for this panel unit rule, panel quantification, Pullman group, etc. Okay. So now, so this is a panel is balanced, right? So actually, if not, it's unbalanced. So this is a example of this balance. So we combination of the cross-sectional together with the time series. So you can see we have a set of y, right? Start with 1 up to y and t. So it's t is referred to the time and referred to the cross-sectional. So if I have 10 years and then 10 countries, so 10 times, right? Yeah. So y is an investment. So let's start with the simple, something like investment model. So y is the investment. So here, so you have to familiar yourself how to write the models. So equation number 1 here, let's say you have n up to n firms. So why I need to write this one until n, right? Because this is a general expression. So let's say I have a 10 firm, right? So I have a 10 firm, did not allow me to write. So allow 10 firms, so 1 up to 10, right? And then t is 1 up to t, big T. So big T here, it depends on, if I say I have 10 firms, then 1 until 10. Then if I have 10 years, 1 up to 10. So investment depends on, it means that econometric models, these econometric models, let's say your y is investment, and it depends on the profit. So x is profit, x is profit. So actually the profit will determine the investment here. And then subscript IT is an example for the panel, means the panel setting in the econometric models. Then A0 here refer to the intercept. Intercept for this equation number 1. And UIT here is referred to the residual. Residual, which refer to other variables that affect the investment, but not take into account in this equation number 1 explicitly. Actually, it's not only called residual, it's also called as the error term. Sometimes they use interchangeable. If you refer to the econometric textbook or you go through the journal articles, some of them they say you actually refer to the error term, some of them say refer to the residual, then refer to the disturbance term. Actually, they are same. Means refer to the other variable that affect the y, but not in the equation number 1 explicitly. And this residual is follow the normal distribution with mean equals to 0, variance equals to sigma power of 2. So we have the assumption. So equation number 1 depends on assumption. So make about the intercept and then slope coefficient and the error terms. So what are the assumptions here? So assumption here, it means you have to assume the intercept and slope are constant across the time and firm. So they will not change. It means they are not time varying, right? They are constant, right? Across the time, they are constant. And the slope coefficient is constant, but the intercept can be varied over the firms. So if we focus on the firms, right, then is over the firms lah. If you focus on the country, will be different lah, over the country. It depends on what is your I. My I here is refer to the firms, right? Yeah, refer to the firms. So the slope is constant, but intercept can be different across the countries, across the firm here. So each firm going to have a different intercept. So intercept is referred to what? When x equals to 0, intercept refer to the value for the investment. So when y equals, it means that different firms going to have a different investment level, right? So when the profit equals to 0. And then the slope, same, right? Intercept varies across the firm and over the time. So the slope constant, but the intercept can be different over the firms and also over the time. So that is, I think, similar things, right? So, and then all the coefficients vary over the firms. So because different firms will have a different constant, so they're going to have a different intercept. They have a different intercept, right? So how about the slope? The coefficient, right, for the slope, it means that this one also changes, also change across this, something like, depends on your intercept, right, different. So these are the several assumptions. Then actually, then you can see that this option 1, right, on the list, this estimation option 1 on the list. So do you observe any difference? So this is the regression line. Let's say I estimate this equation, right, 1. I estimate that by using the pool OS. So I got the common A0, common intercept, and common slope coefficient. So what I'm going to have? Common, right? Yeah. So this is a pool. So I'm going to have a common, something like a common intercept and common slope coefficient for all the firms I have. For example, I have 4, so I have all the 4 firms are going to have a same intercept and same slope coefficient. But in fact, firm number 1 should be like this, the regression line. Firm number 2 should be like this, 3 and 4, instead of in the common regression line. So this is the statement here. Pool OS may result in the heterogeneity bias. This is called heterogeneity. So because different firms are going to have a different individual effect, so if you put them together, you might fall in this heterogeneity bias. So how you estimate? So actually we can start to use this least square dummy variable approach. It's called LSDV. It's a least square dummy variable approach. It's used to estimate coefficient in the presence of the categorical variables. So we're going to use this dummy, right? Dummy variable means we indicate the 0, 1, 2, 0, 1, right? So in this estimated category variable I include in the model, a set of binary, because it's a binary for dummy, to differentiate amongst the firms. So each dummy corresponds to one level of category variables. So we can take the value of 1 if the observation belongs to the level and 0 otherwise. So this is LSDV. So we regress using this OS and then include the dummy variables only. So what is the important thing you have to be cautious is using this LSDV, right? So it's the presence of the perfect multi-economics. So this is one of the challenge. If you use the LSDV, you might fall in this multi-economy between the dummy variables, because one of the dummy variables can be perfectly predicted from the others. So what you can do, so can we introduce for example, I have 4 firms, can I introduce 4 dummies? Cannot. So I have to reduce one. To get rid from this dummy variable trap. That's why to avoid this problem, all the variables, all the dummy, drop from the models, and that one refer it as a reference category or reference firms. So reference category, then we have to, just like the original one will be the reference category. So we have to apply the rules of n minus 1. to get rid from this dummy variable track. So this slide, right? So we can talk about this fixed effect estimation before we further to this LSTV. So better way to model, right? Each firm has its own intercept. So this is a general model like we discussed just now, right? I discussed just now, but the difference here we have a subscript I. Do you notice that? Compared to the equation number 1, we have a subscript I here. Subscript A means A subscript 0 I. So this is allowed each firm to have its own intercept. So this is known as a one-way fixed effect model. One-way fixed effect. How are we going to estimate? Because each firm have its own intercept, right? So you can just create a set of dummy variables. So one for each firm and include them as a regressor. So you're going to have a set of dummy variables, right? For example, if I have 4 firms, then I have three dummies, right? 3 dummies. So include them as a regressor. Other than that, same dependent, same independent, residual also same. What the thing is, you create a set of dummy variable. So this is also known as a least square dummy variables. So you can see there is no constant in this regression. There's no constant term, just a set of dummy variables only. And each firm is going to have a different intercept, right? Yeah, have your own intercept. If let's say, right, I have not only 4 firms, let's say I have 100 over firms. Is it quite tedious, right, to create a 100 over constant, or we say all these dummy variables? So you can use differencing. You can use the differencing. That's why we call the mean method. The mean method. So you can use this the mean to get rid of this. What we say individual effect. So you can see I spread the variable as deviation from their group mean. So for example, the white bar here refer to the mean for the investment, and the X here bar refer to the mean for this profit, right? The mean series line. So we just use the difference from the group mean, and then for the residual mean as well. So that is what we say the mean approach. The mean approach in this equation number 5. Then how about if because some journal articles they talk about the two-way fixed effect. Not only one way. One way is this one, right? One way only. Just focus on the intercept. Then how about the two-way? For a two-way, is allow intercept to vary across the different time period. So you can see you have a subscript. This one, right? Also have a time. Also have a time here. So the time also allowed to be different like IT here. It means that not only each firm have a different intercept, also have a time, different time. So can be varied across a different time period. So have a 2, not only 1, including the time as well. So this example, two-way fixed effect models. Two-way fixed effect. So actually make it simple, right? Make it simple is analytic time invariant unobserved effect. So that is something like the multiple regression, right? We just have to handle this AI here, what we say the individual fixed effect. So in order for us, just now we talk about we can just using the mean, right? Yeah, we use the mean. Using the mean, it means that the deviation to eliminate, right, the AI from the estimation. So another method is you can represent it as follows, right? We can make it general. So it's a mean, right? The A here, and then the AI, right? This AI is constant all the time and does not have a bound because we are not focused on the mean, right? We just not focus on the average. So you subtract means that you just using the mean approach just now, the mean approach. So this one you can get rid from this AI here because the AI A subscript I will disappear, right? It's disappear. So this is a transformation to eliminate the constant as well. So you can see the constant also disappear in the model already. So you can just simplify, rewrite it as follow. They have a dot here. Actually, the dot here refer to the mean, right? Time the mean data on the y. This is the time the mean data on the y. You also time the mean data on the x, IT1, etc. So actually, what we want to do here is we want to get rid of this intercept, right? So that is another approach called Demin, right? The Demin approach. So you can Demin equation 8, right? This one, equation number 8, based on equation 8 here. You estimate this equation. So and then we just estimate using OS. We estimate using OS, and this is called fixed effect estimation. So actually, this is another way to get rid from this individual effect. You use the Demin approach, right? You're using the y minus the y bar, x minus the x bar. You mean for the individual regressor here. Then you do not have an intercept in this equation. Then you run OS for these models. So this is called fixed effect estimation. Okay. So if you ignore fixed effect, like just now the diagram, right? This is the true one. This is the true regression line. But you ignore the fixed effect, then you estimate the poor OS. So there is a difference. So you're going to have a different policy implication, right? Especially about the profit on the investment. Profit on the investment. So there is a challenge here. So there is an example. Moderate. So moderate is I get from the Woolrich paper. There's a Woolrich textbook. So it's a single year, right? Yeah, single years, and then cross-sectional models, and what you observe from this regression line. This is a regression line. After you estimate, you will get your regression line. So actually, you can see the moderate, right? The moderate is increased with the execution. So the moderate is increased with the execution, right? Because it's positive. It's positive. My dependent variable is the moderate, right? And then my independent variable is the execution. So the slope is positive. So increased moderate, it means that increased execution, but increase in the moderate. So because it should be what happened? Something wrong, right? Something wrong. So if you use this panel data models, if you use the panel data model, actually you will get the different result. And this is much more rational, right? Much more rational. Because if you expand your sample, because this is just focused on the cross-sectional. If you expand the sample to combine the time and the I, for example, you start using the fixed effect model to estimate the panel data from 1990 to 1993, right? Then you found out that actually the moderate is decreased with the execution. So that is a much more rational as compared to the cross-sectional analysis. So that's why you come up with a consistent, right, with the one statement we mentioned just now will give much more precise something like the result, right? So, but you have to bear in mind that these actually there are several challenges by using this fixed effect. So bias, what bias is it? Because we assume the unobserved heterogeneity is time invariant, right? Time invariant. Because we assume that this fixed the individual effect time invariant, and if this assumption warranted, it means you can produce the bias estimation. So that's why we have to use the diagnostic check, right, to check it, make sure we do not our result will not bias. And let's say if the individual effect is captured in the residual, then if you use the fixed effect, also will be biased, right? So in order to get efficient, right? So make sure there is it means that there's no correlation between the residual and also the individual effect. So that's why we come up with this sentence here. Fixed effect model can also be less efficient compared to the random effect when this individual effect actually uncorrelated with the independent variables. Because random effect model, there is a different story because the residual is captured in the, it means captured together with this individual effect. But if we ignore this, will make our fixed effect models become less efficient. And also time invariant variables, because if we estimate the panel, right, because some data set, for example, panel, most of the panel analysis, they focus on the annual data set. Annual, right? Annual data set. And this annual, some data actually is a very static one. Just like your heart rate, right? Just very static. Right? So cannot account for the effect of time invariant variables. For example, the gender, race. This is just like the example, female, right? Female or the male or race. But how about, because they are same across the time period, right? Let's say the data set, for example, the income inequality. Some data, right, for certain country, actually they are static one. They are very static. They're just same only since 1990 up to recent years. They are same only. So in order to get means that for this time in very static variables, right? So we can only include it as a controller in the models. And this one time consuming. Why time consuming? Because it can be time consuming if you deal with the large data set. But I don't think we are doing manually, right? I don't think we do it manually. We are using the software to help us to estimate. So I do think this is a limitation, right? So you just bear in mind, because if you have a large country, for example, many countries, so that's quite tedious, right, for us to run this fixed effect, right? Because we have a different dummy variable, for example, or it means each equation for each country, it means for each observation. So that's quite time consuming. But with this advanced something like the recent with these tools, so we do not have this limitation anymore. Like this is something like we not estimate the coefficient accurately if we have a limited variation. Something like the time invariant variables, right? So static variables, we have to be caution. That's why we need to plot our data first. We have to understand, we have to make friends with our data first before we start the estimation. Once you find out that the data set actually is a static across the year, then you have to be cautious. You have to be cautious, and you have to be something like check it differently as compared to other time variance variables. Okay, so we estimate the pan data with these e-views. So we just start with the OS and then fixed effect models. Then after that we will follow by the random effect later. Okay. So we are going to use this Grandfield's models and also Grandfield's data set. So this Grandfield consider the following investment function for the 10 firms in the US. So how to rate this equation, right? Investment as my dependent variables. Then this market value of stock and also the capital stock as two of my independent variables. And this epsilon is a residual, refer to the other variables that affect investment. And the 10 firms are, I think, General Motors, I think they are the different name, right? I think it's a general, I'm not sure. If you want to know more this Grandfield, right, perhaps you can push here. Grandfield data set. Also available in StarDAO. Yeah, this one. what are this abbreviation. So now, what I want to do here, yeah. So use this graphical data, right, over the period 1935 to 1954 for this exercise. So how? We go to my work files, right? So there are two files here. One is a copy of one field. Actually, it's the data already put in the work files. Work files in the e-views work file. Another one, you try to open this Excel sheet. Right, this Excel sheet. So how to read this Excel sheet? I have an INV, I have a CAP, and also VAL. So CAP, VAL actually refer to my independent variable series, right? And I have a question mark here. That's not a question. This is not a question. Question mark here refer to the commands in the e-views when you want to input data, especially the panel, right? In the e-views, we use the question mark. So after that, the brief idea is once we introduce the question mark, means that we put the INV question mark, CNP question mark, VAL question mark. Then you see how I arrange the data set. I put here GM, right? Start from 1935 up to 1954. This for one batch, right? One batch. Then followed by the US, right? And then one batch up to 1954. Then start again with the GE 1935. So that is for 10 firms, for 10 firms. And then how many years is it? 10 firms, 10 years. 20 years, yeah. 20 years, 10 firms. So we're going to have a 200 observation, right? 10 times 20 years. So we're going to have a 200 observation in total. If I just focus on one firm, for example, I just have 20 years, right? 20 years investment, right, for those in US. So I just focus, for example, GM only. Then people will question you, why just focus on GM? Why just focus on US, right? Then why not I focus on the 10 firms or even many firms, right? Then I combine all the information to make it become the panel. Right. So I'm going to have a 200 observation instead of 20 years. 2 instead of 20 observation. So I can before we open what we can is before we open this work files, so I just copy all this data set from the column B up to column D, right, for all my 200 observations. Right, so I copy, right click, copy. Then I open my e-views. I go to File, New, Work File. File, New, Work Files. Right. Once I open the e-views, right, go to File, New, Work Files. So here you can try to structure, right? The work file structure, you choose the balance panel. You can choose the balance panel. Frequency is annual, right? 20 years. Start date, where's my start date? 935 up to 1954. Right, this 1954, 935. So start date 935, end date 1954. I go to e-views, start date 1935, end date 1954. open my another file, right, you cannot see this one, additional notes, right? Yeah, same lah. Right, you can open my additional notes. So same lah, right? Identify 1954. After that, go to choose the prop create pool. You go to the eViews here, you click OK. You go to prop here, right? 1, 2, 3, 4, 5. Number 5. PLC prop. Where's my create pool? Wait, choose prop create pool. Prop here, sorry. Prop here. I think same, create pool. Not here. Quick. Let me think. Object. Should be object, object. New object. Pool. Object, new object. Have to change here. Who type this one here? I think it's me. Object, right? Object, and then new object. Create pool. Hey, click OK. So you have a pool panel here. Again, you go to prop, object, go to object, and then choose new object. Then you can see the pool here, right? Got the geomat, got a model, got a pool here. You click OK. Yeah, here. You put panel. Hey, okay. You here you put panel. Hey, click OK. Are you okay? After you click OK, right? You see your work file got a panel here. Right? The work file, you have a panel here. So I put the years already, right? I haven't put the cross sectional. So you have to type in what we say the firms, right? Firms name. All my firms name. This one. You have to follow, if you first one you put GM, then you put that GM, then followed by US, then followed by GE, followed by CH. You cannot mix it up. If you mix it up, eViews also will mix it up, right? So you copy this one, my column F, you go to eViews here, you just paste that. Not yet, yeah? The tricky part here, you have to put in underscore. This is called cross-sectional identifier. Okay? This is called cross-sectional identifier. So you have to enter this entity, right? Entity below this line. You mean you just below this line, you just type all this 10. But you have to put in is it this one called underscore? Thank you. So you have to do some modification, put the underscore in front for all these 10 firms. Or maybe in your Excel just now you already type it up, right? If not, you modify here, same.
PDF file just now? No, additional notes. My file in the, no, my file in the spectrum. The additional, yeah, no benefit. Go down. Wait, you want to create a pool, right? You go to view, go to stock. New object. Yeah. And then new object, the first one. And then choose the planner, choose the pool. P-O-O-L. In the middle. And then name it as a planner. And then okay. And then yeah, the cross identifier, right? On the right hand side, you type the firm name. So not on the right hand side. Type the firm name. The firm's name. Or the transfer. Okay already. You have to type like me. You see my left hand side?
So once you key in all these it means that the identifiers, right? You can go to where? Yeah. So remember the space. It means that you go to step data. Yeah. Go to view step data. That's how you read these notes. You mean go to the view and then spreadsheet step data. You go to view spreadsheet step data. In this cross identifiers, right? Cross-section identifiers, no matter you are firms or countries, you also do it here. Then you go to view, spreadsheet, stat data. Then here you have to put in your variables. So you have specified with the question mark here. Yeah, that's not typo, it's a question mark. So why? Because there's a command in the question mark refer to the identifiers, no matter it's a firm or countries or individual. So how you type this? You type of the series of investment, for example, in my case, investment, right? So I have investment, CAP, VL. So make sure you space lah. Make sure you space. Means that you type investment space CAP question mark space VL question mark. Why? Because if you make it together, you will only have one, right? Instead of three. So no need to have this colon, just these three. Why? Why IME first? Because my data set is start from the IME, right? IME CAP VL. So I go to eViews, I just type my IME question mark, CAP question mark, VL question mark. You just click OK. Once you click OK, then you can double check whether your cross-sectional similar like your Excel sheet or not. GM 935 up to GM 1954, right? And then accordingly. So you have to make sure same, you're going to have a 200 observation, right? Yeah, something like that. Double check, is it 10 form is here or not? Normally I just check with one, GM, right? Then check with the last one, then should be okay. Then after that, what to do? Copy, right? You have to choose the edit plus, right? And then copy data in the Excel and then paste in the eViews. So what to do? Just now you copy already, right? Am I copy already?
No.
Okay. Not yet, right? Copy already, right? But I click here, click there, then miss out already. So I copy. I go to my eViews. Here you have to choose edit plus or minus. If you don't choose this one, or you cannot copy, you cannot paste anywhere. So plus edit plus stroke minus, then you paste. So once you paste, double check back, same or not. I will check with the first observation and then the last one. Just double check back, are they same? If they're same, then it means that you paste it correctly. You paste it correctly. So that is my data set. Are you okay? If you copy paste the variable name, make sure you paste at the first column, first row, right? If you just copy the data, right, just values only, you start from here, then you just paste in the second row. Okay, depends on how you transfer the data inside. So what I want to say here, as you observe the work files, you can see all my 10 CAP, right? CAP for my 10, means CAP for my 10 firms, investment for my 10 firms, and also VL for my 10 firms. So now I want to estimate, right? Estimate. So you can choose to estimate. Use the common. We will start with the pool OS first. You choose to estimate, right? Because I want to estimate my models. What is my models? Again, my model is, where's my models? Wait, this is my models, right? Yeah. I have investment, VAL, CAP. This is my econometric models. Okay. This is a C. Refer to the constant. Right, constant. C is constant in the eViews. Then you go to the eViews here. You can go to estimate. Let me see. Here. So in the small button here is beside the title, there is an estimate. You click estimate. Dependent variable will be my investment. Am I right? This is my dependent variables. My investment function, investment is my dependent, investment question mark. Why question mark? If you don't put question mark, all you use to know what is this. Investment question mark. Then about this fixed and random, we let it first. Weighted, which also let it first. So I just focus on the common coefficient. I want to start with the OS. So what are the independent variables? CAP, question mark, space, VAL, question mark. Right? Yeah. CAP, VAL. This is a common coefficient. So you're going to return you the commons in the set, commons, what else? Commons slope coefficient for the CAP and VAL. Method. Method. Once you scroll down method, there's a two-state least square and also least square. Two-state least square is want to tackle the endogeneity issue. That one is another story. This one is two-state least square. It's a least square method, but it's tackled in the two stage in order to get rid from this endogeneity. So sample 935, 984. If the question asks you to adjust, for example, because this is my full version, right? 935 up to 1954, right? It's a full data set. Let's say the question asks you, can you estimate the pool OS from the sample 1935 up to 1950? If you say yes, you just adjust here, right? Yeah, you just adjust here. So if you say no, you mean I want to estimate the full version. Then just sample full version. Then when you click on option, right? Beside specification, there's an option. Option here, as you observe, there is a covariance method, right? Then we have the ordinary, we have the what we say the cross-sectional shear, we have the cross-sectional wedge, we have the diagonal. All this one is used to accommodate this autocorrelation and also cross-dependency. That's what we discuss maybe next week, right? So okay. So other than that, you just click OK. So congratulations, this is your panel full OS result. Are you okay at this page? You go to estimate, right? And then just type your dependent variable, and then followed by your independent variable in the common coefficient. Then you click OK. Again, estimate. You just need to type the dependent variable, and then constant, and then your independent variable. Then you just click OK. Right, this is my result. How are you going to read your result? This is my pool OLS. Oh, wait. Okay. Yeah, same, right? Same. This is my pool OS. So how are you going to read his result? Let me see. So this is my method, right? Pool OS. Sample, correct? 20 firms. Oh, sorry, 20 years. I think I'm probably trouble here. Discount. So it's a pool OLS, 20 years, 10 firms. Totally is 20 times 10 equals to 200 observation, right? And now I have a constant. C refer to the constant. M actually refer to A, right? Refer to the N0, right? Yes. In our slide. CAP, VAL. The question mark here refer to the panel, right? Panel setting up, right? For the 10 firms. For the 10 firms. This is our understanding. So this is our coefficient. So what is my model? That is my model. Oh, it's a better so small. I can make it big. Okay. So this refer to my beta 1, this refers to beta, right? Coefficient refer to the beta. This is a standard error, this is a test statistic, and this is a p-value. Right? So how we get the test statistic? So this is your statistic class, right? So the t-statistic we can get from the beta divided by the standard error for the beta. Right? So you just use coefficient divided by the standard error, you will get the test statistic. Am I right? Yeah, right. And then the p-value. So all the p-value here is lesser than the, if I use 5%, means 0.05 alpha, right? So less than 0.05. So all of them actually significant at 5%. Is it good? Oh, so it means that this investment equation, my market value and also little stock actually significant influence the investment model for these 10 firms. For these 10 firms. So BAL, CIP, actually both of them significant impact the investment for these 10 firms over the sample 935 to 1954. So this is how we interpret from the result, right? So about the R square is 0.8 for this panel, so it means that 81.34% the variation in the investment explained by my estimated models. But just the R square, actually this one is used to compare to the models. But maybe you want to compare the models with the BAL and then compare model without BAL, you can use the adjusted R square to compare. This is one of the information criteria to compare amongst the competing models. So there is a pool OS. So if you want to, yes?
What about the diagnostic check? Whether the model is
Yeah, you can. That's why in this panel, right? People will type random is a pool versus the random, fixed versus the random. There's an diagnostic check between the models. Yeah. Either this fixed effect, is it something like the you mean how to tackle this fixed effect? Is it that sharing the common one? Common that do not have an individual effect? Maybe you need to allow for individual fixed effect, like you have to use a fixed effect model, because these three different estimations will provide you with the three different slope coefficients. Yeah, so three different models. So there is a normally diagnostic check that people use, for example, the Hausman, the Ragan-Aldirai Bush-Crossley test. And also, you also can test for the cross-sectional dependency. So to see whether there is a serial correlation amongst the residuals or not. That is a diagnostic check for the panels. Right? So if you want to check for the diagnostic check, for example, the multi-quantity, you can use the correlation test to see whether there is a multi-quantity between the CAP and BAL. But as we mentioned just now, actually we do not need to care much on this multi-quantity in the panel setting. So we're more concerned about how we tackle this individual effect in the panel estimation. So that's why diagnostic check include the serial correlation also, and also the what we say this difference between, it means that the choose between the models. That's diagnostic check we much more concerned. So yeah, okay. Oh, let's take a break. 732. Let's take a 10 to 15 minute break. Then we come back here to we go through the fixed effect. Okay.